Welcome back, physics fans, and here we go with our fifth question of today on circular acceleration, centripetal motion and uniform circular motion. A 1,200 kilogram car rounds a curve of 50 meters radius at a speed of 90 kilometers an hour. What's the centripetal acceleration? The centripetal acceleration, whoops, let's just go back to a red pen. Centripetal acceleration is just v squared over r, and we got to convert this 90 kilometers an hour into meters per second. So 90 divided by 3.6, our magic number. 90 divided by 3.6 is only 25 meters per second. So 25 squared divided by a radius of 50 meters. That's going to be 625 all over 50. And 50 goes into 600 12 times, so that's going to be about 12 and a half, my guess. 625 divided by 50 is an centripetal acceleration of 12.5 meters per second squared. The next question I asked you to do was, what is the centripetal force needed to cause this acceleration? And that centripetal force Fc is MAC, and it's a 1,200 kilogram car, and it's accelerating at 12.5 meters per second squared. So we take this up and multiply this by 1,200, and then this is 15,000 newtons. Okay. And now the next question is, and yeah, surprise, you didn't know that there was more questions, but we got to do it, is what is the force that's generating this net force? What is the force? There's only one force that is pointing in, let's make this, in that direction, because that's where the center of the circle is. So drawing a little free body diagram, yeah, we have a car and it's a normal force and there's a force of gravity, but there has to be a force this direction. Why does there have to be a force that direction? Because the centripetal acceleration is that way. There's a net force that way. The net force is that way. So there has to be a force that way. And that's the net force, the centripetal force. There's only one force that could cause that. If you take a look at it, if we took friction away, the car wouldn't turn. So it's friction that's pushing it. So it's a frictional force that's pushing it towards the center. What is the force that's pushing you outside? What's that force that's making you lean to the right in the car? There is no force. That force does not exist. But I could feel it. Yeah, but you're being accelerated. You're not in an inertial reference frame. That's what they call it, an inertial reference frame. You're in a reference frame that is accelerating, so you feel forces that actually don't exist. And it's the car that's pushing you towards the center, and it's your body that wants to continue off the road into the bushes. And that's the force that you think, and it's called inertia. It's not a force. Okay, so then, if that's the case and you understand this now, if you're following it, trying to be tricky here. What is the coefficient of friction necessary to produce this force? This is a horizontal, so we're going to cheat a little bit. we know that the force of friction is mu m. That is the force of friction. That's how we determine the force of friction. And on a horizontal surface, the upward force is equal to the downward force on a horizontal surface, because the sum of the forces in the y direction have to equal 0 on a horizontal surface because you're not accelerating up or down. So the force of gravity is the normal force, and that is just mg is the normal. This is on a flat surface. So we can write force of friction is equal to mu mg. If the force of friction necessary is 1500 newtons, what coefficient of friction is necessary? Well, this car has a 1200 kilogram, and it's 9.8 newtons per kilogram is the gravitational field strength. Calculating mu, we divide this by 1200, and we also divide it by 9.8. And we get mu is equal to 1.275. That's the coefficient of friction that is necessary to make this car corner at a speed of 90 kilometers an hour in a radius of 50 meters. What do you have to tell me about that? Well, after we just finished a force chapter a while ago, you will know that coefficient of frictions are generally 0 to 1. 1 is very rough surface. Okay? 1 is a very rough surface. That's about as high as you'll get with rubber tires on a road, unless you do something really tricky. So does this car make this corner? No. He tries, but this car goes into the bushes. He's driving too fast because there's not enough friction. The friction here is not necessary and not high enough. He needs this much friction, but he only gets this much friction. So the car goes into the bushes. Slow down.